Hello, welcome to class. Welcome to Top 10 Chemistry Academy, where chemistry is made easy for you. Chemistry practicals that involves calculations under redox titration. We are going to redox titration today. When we talk about redox titration, it involves oxidation and reduction. And when you want to treat a question like this, first thing to know is to be able to identify the oxidizing agent and the reducing agent. These two things are important under redox reaction. Let's move to a question. Let's see what this is telling us and what to do about it. I have a question A which says 25 centimeter cube of a hot solution of 0.0302 mole dm cube hydrated ethane acid acidified with dilute H2SO4 required an average of 28.75 centimeter cube of KMnO4 solution to complete the reaction. In this question, we are to solve some problems under this. How many moles of the acid are there in 25 centimeter cube of the solution? B. How many moles of KMnO4 react with 25 centimeter cube of the acid? C. How many moles of KMnO4 are in 1 dm cube of solution? Under this titration, we are pipetting the hydrated ethane which serves as the reducing agent, while KMnO4 serves as the oxidizing agent. And we are given the equation of the reaction, which is KMnO4 plus 5C2O4 2 minus to give 2Mn 2 plus 10CO2 plus 8H2O. This is the equation of the reaction. Under redox reaction, there are some things you must know. The number of atoms, the numbers of electrons, all this must be balanced. Number of oxygen, they must be balanced in the equation. Now, from the question, the concentration of hydrated ethane has been given, the volume has been given, while the required average of KMnO4 has been given, which is the volume of acid used. And this volume, after titration, you are going to discover that in this, we've made our titration. Now, let's see how to go about this. Let's go to question A. This A, the solution, says to calculate the amount of acid in 25 centimeter cube of solution. See what we're given. The concentration in mole per dm cube is equal to 0.0302 mole dm cube, while the volume of acid is 25 centimeter cube. That is the volume of the ethane acid, while the concentration of ethane acid is 0.0302 mole per dm cube. The question says calculate the amount. When we are talking about amount here, it's talking about the number of mole. The unit will be in mole. The number of mole or amount is equal to concentration in mole dm cube multiplied by the volume in dm cube. Please note, in this place, the volume is given in centimeter cube. You need to convert it to dm cube. How? You divide, you use 25. See, from this thing that I work, I use 1000 to divide 25 to have your answer in dm cube. Now concentration says is 0.0302 multiplied by the volume, which is 25. To convert to dm cube, you divide by 1000. The answer will give you 0.00755 moles. The unit must be in mole. When you see calculate the amount or the number of moles, your answer will be in mole. Let's move to another question. The B part, which says to calculate the amount of KMNO4. The amount of KMNO4 from our question. You see 5 moles of C2O42 minus. From the question, you have the 5 moles, which is equivalent to 2 moles of KMNO4. Now, our moles, the amount that we've gotten from question A, which is 0.00755 moles of C2O42 minus, is equivalent to 0.0755 multiplied by 2 divided by 5. You just cross multiply. When you cross multiply, you get the number, the amount of your KMNO4, which is 0.00302 moles. Please always remember your 3 significant figure. The next question, which is amount. I see amount of KMNO4 in 1 dm cube. That shows amount of KMNO4 in 1 dm cube says amount of KMNO4 in 1000 centimeter cube. In 1000 centimeter cube. And the volume of KMNO4 in the solution used is 28.75 centimeter cube. That shows it's not in 1000. That shows that volume, that is 0.00302 moles. That is the amount we've gotten for KMNO4. That amount is just in 28.75 centimeter cube. We want to know the amount of KMNO4 in 1000 centimeter cube. That is in 1 dm cube that contains. It will now be your 0.00302 multiplied by 1000 divided by 28.75. Now, the amount in 1 dm cube will now be 0.0105 moles. 0.0105 moles. That is for that. I have another question. We have different questions that involves oxidation and reaction. That is redox titration. Let's go to second question. This second question says 10.0 grams of impure iron 2 salt. Impure iron 2 salt. In this question, you might be given the pure. But here too, under this, it will tell you to calculate the mass of the pure iron 2. But let's go on, wait and listen to the question. 10 grams of impure iron 2 salt were dissolved in water and up to 25 centimeter cube. That shows that 10 grams was dissolved in 250 centimeter cube of solution, while 25 centimeter cube of this solution acidified with dilute sulfate 6 acid H2SO4 required 20.10 centimeter cube of 0.050 mole dm³ of KMnO4 solution before a paint pink color appears. This is during the titration. You have the volume made for the iron 2 to be 250 centimeter cube. And after the titration, you got the volume of the acid used to be 20.10 centimeter cube. On this concentration of, that is the molar concentration, is 0.050 mole dm³ of KMnO4. Our KMnO4 is purple. After titration, you must be careful while reading your endpoint. When you discover a faint color, please, you stop your reading. You read at that point. The equation of reaction is 5Fe2 plus MnO4 minus plus 8H minus to give 5Fe3 plus Mn2 plus 4H2O. Here, KMnO4 is the oxidizing agent, while the iron 2 salt is the reducing agent. Now, from this question, we have some questions to solve. How many moles of iron 2 ion react with 1 mole of MnO4 minus from equation of reaction? B. How many moles of KMnO4 are used in the reaction? C. How many moles of Fe2 plus react with 20.10 centimeter cube of KMnO4 solution? D. How many grams of Fe2 plus are in 250 centimeter cube of original solution? E. What percentage of mass of iron in the impure iron 2 salt? Let's go and solve the problem. The question in A says, how many moles of iron 2 ions react with 1 mole of MnO4 minus from equation of the reaction? In the equation of reaction, we can see that 5 moles of Fe2 plus reacted with 1 mole of MnO4 minus. Now, the number of moles of iron 2 ion that reacted with MnO4 minus is 5 moles. That is just the answer, 5 moles, because the question says from the equation of reaction, it's just 5 moles. The other question says, calculate the number of moles of KMnO4. The number of moles of KMnO4, which says concentration was given, which is 0.0500 mole dm³. That's the concentration in mole dm³, while the volume is 20.10 centimeter cube. This 20.10 centimeter cube must be in a standard of 1 dm³. That shows this is 0.0500 mole per dm³ is in just 20.10 centimeter cube by volume. You must calculate the amount in dm³. That shows amount will now be equal to concentration times volume in dm³. Now, it's equal to 0.0500 0.500 multiplied by 20.10 divided by 1000. Our answer is 0.001005 mole. Now, please, I told you remember your three significant figure. You have 0.00101 mole. That is your answer. Please take note. Amount is equal to concentration times volume in dm cube. Always remember your formula. Write correct formula always. Let's go to the C part. To calculate how many moles of Fe2 in 20.10 centimeter cube of KMnO4 from the equation, 1 mole of MnO4 is equivalent to 5 moles of Fe2 plus. Now, they said in 20.10 centimeter cube. The one we calculated was in 1 dm cube, which is in 1000, which is equal to 0.0101 mole of MnO4 minus, which is equal to 5 multiplied by 0.0101 divided by 1, which will give you 0.0050 mole. That shows 0.050 mole of KMnO4 is in 20.10 centimeter cube. Please calculate well during your examination. Practice the more. Follow the guide and use it at home. D. Calculate how many grams of iron 2 in 250 centimeter cube of original solution. 250 centimeter cube of original solution. 25 centimeter cube of Fe2 plus is equal to 0.00505 moles. Now, in 250 of Fe, it will be 20 multiplied by 0.050,505 divided by 25, which gives 0.0505 moles. Now, to calculate the mass, we want to calculate the mass. To calculate this mass is equal to amount. The amount given multiply in moles multiplied by molar mass, and our molar mass is a gram per dm cube. The molar mass of iron 2, that shows the relative molar mass of iron is 56. We are using that because it's just an element, not a compound. That's why we have it as 56. The amount gotten was 0.505 moles multiplied by 56, which is equal to 2.827 grams. You can approximate it to 2.83 grams. That is the grams in 250 centimeter cube. That is the mass in grams in 250 centimeter cube. Now, the next question says percentage of pure iron in pure iron salt. We were given in impure iron, and the impure iron was 10 grams. That was the mass. But we've calculated the mass of the pure, where in our D1, where we got 2.83 grams. That is the mass of the pure iron. Now, to calculate the percentage of purity is equal to mass of pure over mass of impure multiplied by 100. Mass of pure over mass of impure multiplied by 100. Now the mass of pure is 2.83, while the mass of impure was given in the question, which was 10 grams multiplied by 100, which will give us 28.3%. 28.3%. Now let's say peradventure we have a question which says the percentage for the impure. After getting this, you just subtract it from 100. That shows 100 minus 28.3. 100 minus 28.3, which will be 71.7%. That is the percentage of the impure. That is how you will it's so simple. They can tell you calculate after calculating the percentage for pure, you can calculate the percentage of impure. Just subtract it from the one you have gotten. Please take note, read well, study well, follow the teaching, practice more in your house, in your different homes. WAEC is at the corner. WAEC practical is coming up May 16. Please, you need A1. Work hard to get it. And your getting A1 starts from your practical class. Thanks for listening. Subscribe, like, share, and remember to press your notification button. Thanks for listening.